physics. That core idea, once you understand, you can manage later. So there's a simple microscope. So what is a simple microscope? Reading lens. In a common language, it is called as a reading lens here. How do it will work out? Now you know some idea of the optics. So first what happens, there's an object is there. So what is the definition of this one? Subtended by the object at unaided eye, kept at distance of I'll complete this distinct vision. This was telling. So this should not be less than D in the definition, because I should compare. No. So what is the compare? With respect to capital D is what I'll compare it. So there's a reference what they have put it. So I should have uniform. No? So you cannot. So why they kept capital D? Why not they make 2D, 3D? So you design equipment keeping the least distance as 25. Some other will take 30. Some other will take some 40 centimeters. So to have uniform, the least distance is what they've taken reference. Got the idea, no? So that's what the basic condition is put. This is what for magnifying power for microscope we define like this. And let's come for this one. So this object is kept. This eye, unaided eye it is. So it will subtend an angle, and that angle is what we'll write alpha. Now what happened? The same object, it is viewed with the help of an equipment. That equipment is what I'll call the convex lens. Focal length of this BF, and this is the eye. Where the object is kept here, the same object. This H naught, this object, let it be at a distance U. The image will be formed the image will be formed. I think any condition for you should be less than F or greater than F. Convex lens, you go back to ray optics. You go back to the ray optics. If the object distance is less than focal length, then what happens? A virtual image will be formed. So this U should be less than F. So that F of the lens, I'll show it here. Agreed? No? Then form a virtual image. No? And this image is virtual. This is a lens. Huh? This is a lens having focal, and this is an eye. Now tell me, like the eye, what it will see? Will it see object or will it see image? Say, I think you must have the reality here. So reading lens, you view it, what you see? Will you see object or image? You see the image of that object. You don't see that object. You remove this lens, you see only object. If you keep the lens, you see only image. So what eye says, I am seeing magnified image. Later on, I'll give 3D diagrams. First, we will start with the basic thing. So this is the image distance V. What is our definition? Magnifying power, and this is angle subtended, no? Beta. So what is our definition? Magnifying power, angle subtended by the image at the eye with the help of instrument to the angle subtended by the object at the eye when the object kept at a distance of least distinct vision without any equipment. So there's a beta. So beta from where I'll calculate? From the diagram. What is the beta? Tan beta books what happened, they have shown both alpha, beta in the same diagram. They have made a cocktail. That's why you find very difficult. So always keep that the alpha from other diagram. Don't show alpha in this diagram. Don't bring alpha here. Try to avoid. It'll become very simple. No, no. What is beta? This one. What is alpha? Looking at this diagram, HO by D. And look at this similar triangle, HI by V can also be written HOU. So what is the magnifying power given by D by U? D is a fixed here, nothing to do. So the U what happened, by varying this U what happened, you can control the magnifying power. Okay, first case, let the object be exact at focal length. Let the object be exactly at the focal length. This is also the focal length of the lens. Then after refraction, what happened to rays? As we know, the rays what happened will undergo. Let me use this color. And the eye which is present here. So how the rays will enter? Parallel, no? If the rays enter parallelly or nothing but what happened, the eye will feel as if they are coming from far away. Though object is here only, the object is near only, the eye will feel comfortable when the rays are parallel. Sir, what do you mean by this? Go back to the just now concept. If the object is far away, how the rays will enter into the eyes? Will enter parallelly, no? And you can see the image, you can see the object comfortably for longer time. So what should be our equipment? No? Our equipment should be such that it should send the rays parallelly into the eyes. Now the eye, what happened? What eye will say? I am weaving object comfortably. Then what about the image, sir? Where is image? I think image will come from like almost far away. What is the magnification produced? No, M infinity. First we'll get into calculation. 1 by V minus 1 by U equal to 1 by F. If object at focal length, then where the image will be? Image at infinity, no? Because U is equal to F minus F. Then what is the magnifying power? M infinity equal to D by F, because U you are going to put as F here. So what is the magnifying power I got? Just by capital D by small f. What is the focal length of lens? Based on that, what I'll get the magnifying power. So tell me, like, to get a magnifying power, very high magnifying power, what I should do is I should go for lens of less focal length. Agree this? Then give more magnifying power. If you use less focal length, if you take the lens of focal length very less, what is the problem? The shape of the size of the lens will come down. Then if the size of lens, then it will gather less light. Then resolution is a problem. So therefore I have to compromise. Always what happens? Magnifying power, resolving power. These are the two things which we have to make a compromise here. So for a reading lens, this condition arises. So what is the basic idea now? So if an object kept it exactly at focal length, then the image what happened will be formed at infinity. Image formed at infinity means I will not say not like that. I am weaving object, I am weaving image of object, not object, image of object comfortably. You will see that the rays will enter, once they enter parallelly, comfortable weaving will be there. There is a magnifying power when image is at infinity or far away. Shall I say far point when image is far away? Now similarly, when image is formed at the least distance of distinct vision. So where the image, I'll go back to this. Where the image, if this image is formed at a distance of 25 centimeter, then the eye also will see that image, no? Then we'll see what conditions will arise. The same set of diagram. This is a lens. I kept an object. The ray diagram I'll try to avoid. So the image will be formed. What is the condition? The image is at a distance of what? Distance of least distinct vision. Then okay, I'll show the ray diagram. The same ray diagram. There's another ray. We'll take some yellow color. They're not parallel. I think they're not parallel. You can see from here. And this is the eye. What that eye says, I'm seeing the image. And where it is formed at a distance of least distinct vision. And this is U. So definitely this U should be what happened. There's a focal length. There's the object. It'll be there, that one. So what is the formula now? We have formula. Where the image formed here. And this also will be negative. So 1 by U equal to 1 by D plus 1 by F. Then this is a basic formula. So I'll substitute this. So what is the magnification will be? One by U. Tell me in which case magnifying power is more. It was D by F. Now we'll get 1 plus D by F. But what is the problem? What this I will say? Some strain. If you want more magnifying power, what you should do? You should be ready for the strain in eyes. If you compromise with the magnifying power, yes, you have comfortable viewing. That's why you see that when persons who are like in archaeological department or in the museums will collect things, no, they're having a reading lens, that one. And if they want to see things clearly, no, they'll move their lens near to the object. And if they form the image at a distance of distinct vision, no, they'll get more magnifying power. Of course, they can't view, but at least for that small interval of time, they can see things clearly. So like that, the reading lens should be used here. If you want to view comfortably, you should keep the lens at a distance of focal length. See, first time you hold it, you'll never come to know. As you start using, you'll come to know, okay, if I keep object here, I can view it comfortably. The moment you get a strain in eyes, what you should do, try to see, you can't move the object. I think, can you remember? I think when you go for watching some very important things, museum or somewhere, archaeological department, they can't shift the object. What they should do, they should just move the lens a little bit away. As you shift the lens away, so once what will happen, the object distance becomes less than focal length, then we'll see this condition. So when object distance becomes equal to focal length, then they see this condition. If you want the more magnification, then you have to bring this condition. Then you have to see that U should be made less than F. Sir, I'll make U greater than F. Then what you get? You are unable to see things, no? Then object will be visible. The rays what happen will not enter into eye. So therefore, what is the condition? Either U should be equal to F or U should be less than F. Then only you can use this simple you can use this lens for magnifying power. As a simple microscope, this is called simple microscope. So there's a thing. So what actually practically what happened, this I drew only lines, but practically if you see the, let me give some realistic diagram. There's a lens. Okay, we'll keep some flower here. And you want to view that flower and the eye is here. A flower is a what 3D diagram. So what this lens will do, what this eye will see the magnified one. Okay, I have available magnifier here. Oh. I think everyone will enjoy. Who don't want which image you like it to tell me? Will you want to see the tiny flower or you want to see the magnified form? The magnified form, no? You ask the eye what it is waving, two flowers or one flower. It will say that only one flower, big flower. I'll see that one. Is it flower really that big? So who has magnified the lens? So shall I say that lens is equipment? I'll call that a simple microscope. I'll give name, simple microscope for it. Oh, red color, blue color. This is blue color stem. I'll wind up class. Just give you time. Just let me explain this because this will really help you like what you are studying. Because if I don't show this diagram, no, you'll still think like ray optics. I don't know. India is such a good big country. So many institutions. Can't we print some diagrams like this in books? The same old Britishers what happened earlier in 18th, mid 18th century, what they printed. No, that books only we are using. So what that government of India education department is doing, Telangana government is doing, CBSE board doing, I don't know what will happen. One image like this, I think any student can really understand this topic. So what this eye will say, there's a lens, there's a real flower. This is not a real eye, it's an image. Uh, what this eye will see, I'm seeing the big flower or small flower. You will see this one. No? So I'll write one, this two. How many flower? There's a real flower. Again, don't see. This is image I wrote. Image I wrote means it should be understood. So somebody will. You ask him to wave and here. You try to catch this flower. Nothing will happen. The flower is here. This is a real flower, and its image of flower is formed here. So what I see, I'm seeing big and beautiful flower. Big is not small and tiny flower. Big and beautiful flower. Two. One is not visible. It says and one is not visible. Will not be visible. You remove the lens. One will be visible. Two will vanish. Two will not be there. So that's what I think. Better you purchase one reading lens and you can experience this one. So I don't know. One of the years the student asked like a high how many flowers it will see. No, it's not that. You remove lens, you will see one. Without lens, without lens, I will see real flower one. At least able to understand all of you. Now that angle subtended I was telling no. Tell me like here without lens, this particular small tiny flower will subtend small angle, no? Now because of lens, what it is subtending more angle. So that's why the magnifying power is defined in that way. Practically they have seen, okay, like this we have to bring the magnification equation, then they analyze practically, then they brought that equation.